Hello, everyone. Welcome back to Jump On Air. We're so happy you've chosen to spend some of your Monday with us talking about statistics, science, data, and of course, Jump. My name is Julian Paris. I'm the Learning Strategy Manager here at Jump Software, and I get the privilege to be your host for Jump On Air. We have a really great show for you today, full of people who are sharing their stories and sharing their knowledge. And I'm here basically just to help keep things on track. So speaking of that, throughout the program, I'm going to be referring to this program of events, and I promise you I'm going to try to keep us to the minute on track. And I'm doing that for a really important reason, which is we know your time is valuable and you have other obligations. So if you have to leave at any time, that's totally fine, but we hope you come back. And we've made that pretty easy. At any point, just go to jump.com/jumponair, and you'll be connected right back to our live stream. In fact, you can do this from any device you want. You can put us on your iPad, put us on your phone and go for a run. Whatever you want, it's jump.com/jumponair. Before we get going, I just want to tell you a few things that are going to happen after the broadcast and some best practices for how to consume the content. So right after the broadcast, you'll be redirected to community.jump.com, where we actually have an episode page built out just for this program. And we have individual segment pages for all the segments you're going to see, where you'll find on-demand videos and any of the links that our speakers are actually mentioning. So it's going to look like this. You'll just go to community.jump.com. You can even navigate to the Jump On Air section yourself, and that'll show you all the content for the day. All right, so before we get started and introducing our first speaker, I always like to take a minute to talk about something with you and sort of get things going. Last time I did a segment called Today I Learned Something Really Good. Today I'm going to try something different. Today I'm going to try I bought this, and I'm going to tell you about it. Hashtag I bought this. Now, fair warning, none of these products have paid me to talk about them, and they're completely my opinion, so don't hold Jump or SAS responsible for any of these. But any of you who know me know that I love to talk about the things that I buy, especially if I really like them. And so maybe I'll talk about these prism glasses I bought that let you actually read while laying in bed staring downwards, things like that. Actually, what I'm going to be doing this time is talking about something really specific. And actually, I forgot to tell you, there's a long history of me actually talking about things I bought or things that I like. And I was digging through my old web pages, and actually this is my web page back in 1996. There's a lot to unpack here. The color scheme, the fact that there's spelling mistakes, the fact that I called it J. Paris and Company. I don't know who the company was, but it was basically just me. Anyway, there was a section on here called Best Software of the Month. And so if you were one of the lucky 11 visitors I had monthly to my website, you too could read the reviews of a 14-year-old about 16-bit and 32-bit Windows software. And so, there's some on there about MIRC, or apparently I really like Netscape Navigator at the time. Anyway, so I have a long-standing history of wanting to talk about things that I like and that I've bought. So today, I need to tell you about Professor McGonagall before I get into what I'm going to be talking about. And I'm sorry, Harry Potter fans, it's actually not this Professor McGonagall, but a different one that's engaged in a different kind of wizardry. And this is actually Kelly McGonagall, who is at Stanford University. So I actually came across the work of Professor McGonagall about 7 or 8 years ago. I came across this book, The Willpower Instinct, How Self-Control Works, Why It Matters, and What You Can Do to Get More of It. I really recommend this book. Even though I'm not talking about it specifically today, it is a really great book that talks about sort of the neuroanatomical structures of willpower and methods that you can actually employ pretty much right away and today in order to feel like you have more self-control and more willpower. And she's a great researcher and has really thoughtfully put this book together. But that's actually not what I want to talk about. I came across a talk just over the weekend on TED Talks, and I love TED Talks. I love 15-minute segments where people dive into a topic. And I came across this topic of hers, how to make stress your friend. And I highly recommend after our broadcast today, you go watch this, because it talks through really the ways that we think about stress and how that impacts the actual effects of it. Now, without stealing any of her thunder, I'll just show you the graphic they put together. But basically, the main premise is about how the way we think about stress, and that there's a lot of evidence that what our impression is of stress and how we think about it moderates physiologically some of the effects of it. That is, if we think about stress as bad, it can have more deleterious effects. And if we think about it as good or something that's motivating, it has more positive effects. And these actually show up physiologically. And so it's not simply us thinking about things changing the way they happen. Now, this actually isn't even a very new idea. Certainly, psychology has known for a long time that the way we think about things can have massive, real physical effects. I mean, it's not even a new thing for science. I mean, philosophers going back to the Stoics talked about how we understand and interpret the events unfolding before us. So you can read Epictetus or, Aurelius and think about these ideas. But I think she did a really great job talking about it in the context of stress. And so the thing I bought over the weekend I want to tell you about is that she has a new book out, The Upside of Stress. And it's not super new. This is 2016, but I had missed it until now. And I've already started reading it, and it's great. And I think it's a really good one. If you think about stress in your everyday life and the ways you interpret it, this might be a nice way to help you interpret it better. She actually has one additional book that I have to admit I also bought because I love buying books by authors I like, The Joy of Movement. And so she talks about exercise, happiness, hope, connection, and courage. And so these are some things I bought, and now I have told you about them. Okay, so we have a really great show for you today, and I don't want to take any more time away from our speakers. Just to give you a brief recap, if you haven't looked at the program since the weekend, we're going to hear from basically a systems engineer and really Jump expert about things that he wished he knew when he started using Jump. We're going to move on to talking through some topics in Jump Help and learning about the statistics index. We're going to meet a Jump developer, which I'm really excited about. Laura Castro-Schilo is going to talk about her experiences getting to Jump and her work with structural equation modeling. We're going to learn and have you tried how to embed hyperlinks into Jump tables. Phil's going to talk to us about why perform design of experiments. We're going to learn from our DIY data expert about connecting an Arduino with Jump to do streaming data, which is a really cool segment. We're going to learn about creating drill down graphs in Graph Builder, which is a great new feature in Jump 15. And finally, we're going to learn about creating summary statistics with Tabulate. And so also something that I'm sure many of you will get value from. So I want to start by kicking it off with Mike Anderson telling us about things he wished he knew when he started using Jump.
Good morning, everyone. My name is Mike Anderson. I'm a systems engineer at Jump. I'm from the New York area, and I'm coming here from my home office. Great for you to join me today. This segment is based off of a series of blog posts that I wrote last year, and it's also based on a series of seminars that I gave earlier before that, based on some feedback that I had received from some customers, and also some of my thoughts about what I wished I had known being a brand new engineer or being a brand new user of Jump. Day one, I've got a data table in front of me. I've got this thing called the home window. And what did I wish I had known at that point? What if I could sit down with myself at that point and say, what did I really wish I could have told myself? So there's several of these. The original series started out as being 5 things, just 5 of them. I liked the tagline for that, so I kept it, but depending on who I'm talking to, it's anywhere between 7 and 9 now. But it's still, we'll say it's under 10. The first one that I want to talk about today is fairly conceptual. But before I get into that, I want to talk to you just briefly about how this segment is going to go. So I'm going to show you the first thing that I wish someone had told me. And we'll go through some examples of that. And then afterwards, we're going to take a couple of minutes and give you a chance to go into the question window. And if you take a moment and find that question window in the Zoom interface, and I'll take some questions from the people online, and we'll be able to answer those questions in real time. Any questions that I don't get a chance to answer, we'll try and put those up on the page that Julian mentioned earlier. And I'll try and answer those as those get posted as well, so that we can keep a record of everything that you guys wanted to know about during this segment. All right, so let me take you back to when I was first starting as an engineer, and not a Jump engineer. I mean, I had just gotten my PhD, I had just started my job, and I had this opportunity to, during my graduate school years, had a chance to meet with people who had interned at companies that used Jump a lot. So I knew it was something that I wanted to see. So when my manager came to me and said, Mike, I want you to go take this class in Jump. I want you to learn how to use this product. I wasn't surprised. But at the time, the challenge there was the company was fairly new. The place I was working had just been set up. And the training organization wasn't as mature as it is now. The training organization there is incredible at this point. So at the time I was kind of on my own learning Jump. I had a few classes, and I hadn't, at the time, because I didn't know any of these things, I didn't know who my systems engineer was. I didn't know, I wasn't aware of the community webpage, community.jump.com. I wasn't aware of that yet. So the only thing I had was me and my tech support friends at support.jump.com or support@jump.com. And that was how I started learning the software. So it was a bit of a trial and error. It was definitely me learning on the fly. And so this is my hope that those of you that are in that same situation maybe will be able to avoid that going forward. So let's get to the first thing. And this is really conceptual, but it's incredibly important, particularly if you're coming from a coding environment. And that first thing is that Jump, and not just Jump, but we as human beings are visual creatures. We consume data, we consume information primarily with our eyes. And putting something like a data table, for instance, this data table right here that I've got in Jump, putting a data table like that in front of someone, their brain's going to turn off, about row 3 there, in all reality. So everything we do in Jump, everything we do when we're trying to present data, we should try and use graphics as much as possible. And let me give you an understanding about why that is. So here I've got some data in Jump, and before I show you the graphic, I want to show you the data table. Now look at that data table for a second for me. Do you see anything that stands out? Ask yourself that question. We look at the p-values for that. They're all in the same range. You wouldn't say that anything in there is special, other than there's not a lot of significance in this data table, in the comparison that I'm making. The R-squareds, this is from a simple linear model, y equals mx plus b. There's nothing there. It basically looks to be a flat. The R-squared is pretty awful. The intercept, horseshoes and hand grenades, it's the same for all of those different data sets as is the slope. The challenge here is that this data is actually quite wildly different. And as we look into the data itself, we can find that, and I'm just going to go through this, go through these examples here. All of these had the same fit statistics. And because we as human beings, if I were to put the actual raw data in front of you, you wouldn't be able to pick out the fact that we've got all kinds of random patterns built into here that give the same fit statistics. And that's the challenge of analytics. A lot of analytics courses and a lot of analytics texts start out with this idea of graphing of data tables first. So I've been stuck at home like everybody, studying different programming languages, and one of the things that they come up with is they're always talking about data table, data table, data table. And usually the graphics are relegated to one little chapter way at the end in the back, because graphics are hard to create, or so they say. But the point is, even though they're hard, it's incredibly important to do. So the take-home message today for this segment is that you need to be able to graph your data. You need to consume your data visually, because you never know if there's a dinosaur in the data set or not. Now, let me show you another example of this, just for the sake of time, and then we'll get to some questions. And Julian, if you want to get that 2-minute timer ready here, I'll cue you in for it in just a second. Let's look at this data. This is 2-dimensional data, so it's still graphed, it's great. But this 2-dimensional data is from the thickness, going through a thickness of a crystal. And we can see that the hotspots are areas where there is a problem, a defect in the crystal. And that's all you really need to know about that. But looking at this, you might say, if you were going thickness to thickness or image to image, there appears to be something relating these data. But again, humans are visual creatures. So even looking at two-dimensional data when we should be looking at three-dimensional data makes it harder for us to consume that information. Here I've mapped the same information in 3 dimensions. And we can see very clearly that there is a, particularly with that little hotspot, this little hotspot right here, we can see that that hotspot follows through the entire thickness of this crystal, which would be kind of hard to pick out if we weren't graphing it in the appropriate 2 or 3 dimensions. So again, take home message number 1, always look at graphs first. Always be ready to, and we are visual creatures, so we should expect to consume data visually. Julian, and what we'll do right now is I want to take a couple of minutes and give anybody a chance to type in the Q&A section of the Zoom window. If you've got questions, go ahead and type them in for me, and we'll go ahead and we'll answer them right now. So Julian, let's give everybody 2 minutes to type in some questions, and we'll take it from there. Wow, we got some great questions coming in. Let me go ahead and share my screen back up here. And let me get rid of this. There we go. All right, so let's start from the top. Let's start from the bottom here. Well, actually, let's start from the top. So someone had a question about, can I explain the hotspots in the 2D image again? Sure. I'm not going to go into super gory details about this, but what this is this is an X-ray image of a piece of silicon. And the idea behind this image is that when the X-rays interact with the silicon in a way other than what you would expect, you get a hotspot here. And if you're working with semiconductor in the semiconductor industry, you would call this a dislocation or a crystal defect of one kind or another. And that's what we're looking at here. And you can see that as the wafer, in this case, this lowest image, this first image here in the upper left, is the backside of this piece of silicon. And the top, you can see the little circuits that are being etched into the top of the silicon that make up, your devices that you have in the computer you're looking at this right now on. That was a great question. So what visualizations should you start with? Any you recommend? Well, great cue in for the next segment, which is the JMP workflow. How do you start working with data in JMP? And that's the next week's segment. But to give you a little teaser, I always start, since I learned JMP, I always start with Graph Builder, and this gives me the flexibility to be able to explore all kinds of different relationships. I can just start saying, you know, I think height, just as an example here, height and weight are important. Oh, well, that gives me an important relationship, or potentially an important relationship. I could come in and change it to say, I think height and looking at age might be important. And there I can get into things like box and whisker charts. I think the better question is, and this does lead into the workflow a little bit that we talk about next week, is the idea of you want to start with a graph, and then that graph, if it's the right graph for the data you're looking at, will lead you to questions that you can ask. And that's how you know you've got the right graph, is if it starts giving you feedback as to what things you can explore with it. Is there a difference between age in terms of statistical significance, as in this case? So that's how you know what visualization you should start with. Some of it's just guess and check. Sometimes you've got experience with how to deal with it already, and so you kind of know where you need to go with that already. But that's what makes a tool like Graph Builder really handy, is that it gives you the ability to just kind of play the field and explore what's going on. What kind of graphs should I suggest I should do first? Okay, how did I get the solid looking picture in Scatterplot 3D? That's a great question, and I'll do this really quick. So Scatterplot 3D, the way you do this, and I'm going to jump ahead just a little bit. I'm going to assume that you know how to set up Scatterplot 3D, just because I've got a few more questions coming in. What you do is you come into this non-parametric density contour, and I turned off the points because there are a lot of data points in this data set. You can see all the data points in there in black, and they aren't helping matters any. So if I were to do the workflow, I would drag, you know what, I'll just do this really quick. Graph, Scatterplot 3D. I'll drag my values in to my columns. I've got a lot of stuff going on here. So the first thing I'm going to do is I'm going to turn on a local data filter to get rid of the data that I've already excluded. I made a column to tell me what data I don't want to consider in my data set in this analysis. There's my rendered data. And then I come back to my red triangle, non-parametric density. In this case, I had some other analyses that I did with this. If you're interested in looking at this, there's a mastering jump webinar that I did where I kind of deep dive on this data set, where I go through where this cluster came from. And we'll put that up as part of the notes on this section. And that gives me my graph. And I'll turn off my points. And let's up the intensity of that. After this, it's just a matter of adjusting the resolution a little bit to get it to look pretty. So that's how you do that. How about using data table and graphics? That is a powerful combination. Between the two, data tables and graphics, there you're getting into something that's more about kind of, and I don't want to call it a dashboard, but for lack of a better word, a custom report or a custom dashboard, where you're showing both the model and fit statistics. And in general, that's how you see JMP present results. We will show a graph first, and then we will present the summary statistics, we'll present model statistics and things like that. So that's the paradigm that we work in. So that is true. Now, have I used JMP to perform image analysis? Yes and no. There's a lot of ground to cover in that particular topic. Is a data table ever better than a graph? There is one case where I would say something that is data table-like is not necessarily better than a graph, but will do something that is similar to a graph. And that is when you start adding color to the graph. And a really good example of this is right here in our process screening platform. This I would call more of a dashboard than just a raw data table. Data tables by themselves are painful to look at. They're great for computers, not so much for people. But when you start adding color to things, then you can actually start using them as more of an intuitive visual analytics tool. Another example of this, for instance, with Tabulate over here, if I come under the red triangle, I can actually turn off the data table and turn on a chart. So even Tabulate, and there's not that much interesting going on. There's not much interesting going on in this, but it still gives you that idea. And let's see, any that I recommend. Graphs I would do first, 2D images. Okay, I think I've got everything. So at that point, Lady Julian, I think we're good. So again, a little bit of a teaser for next week. Next week, we'll be talking about the workflow that I wish somebody had told me when I got started with JMP. And if you're new to JMP, this will flatten out your learning curve pretty aggressively. It's one of my favorite things to teach people because it really does give you 80% of what you need to know to be dangerous in JMP. So join me next week, same time. I won't say same channel, but there we go. Julian, back over to you.
Fantastic. Thank you so much, Mike. That was really great. And yeah, again, be sure to check out his page on the community episodes and tune in again next week to see Mike talk about more things he wished he knew when he started using JMP. So thank you so much, Mike. Our next section is by Ross. He's going to be taking us through, in every week actually, different parts of JMP help. And so this segment, called Help, not surprisingly, he's going to be taking us through the statistics index.
Thanks, Julian. Hi, everybody. I'm Ross Matusalam, a JMP systems engineer, connecting to you from Tampa, Florida today. And today's topic is playfully titled Help, where we'll be talking about some of the various help resources in JMP and how to use them effectively. Today, specifically, we're going to be talking about the statistics index, which is a great place to go if you know of a statistic or analysis you want to do in JMP, but you're not sure exactly where to find it or how to use it. So let's take a look at a simple example. Here is a data table containing download speeds in megabits per second of my home internet connection, where many of us are working from home, as of late, and internet speed's particularly important consideration for us. On my bill, it says that I should be getting about 100 megabits per second on my connection. And so I was wondering if that's actually the case. Here I've recorded 12 download speed tests over the course of a few days, and I want to actually see if I'm getting that 100 megabit speed that I'm paying for. Let's take a quick look at a basic analysis of these data. It looks like there's some spread, but on average, I'm getting 104.17 megabits per second. So that looks pretty good. I may actually be getting a faster speed that I'm paying for, but in order to assess whether that really is the case or whether this might be due to random chance, I want to do another analysis. In particular, I need a one sample t-test, but maybe I don't know exactly how to do that in JMP. I need some help. So let's go ahead and see how the statistics index can help us in this situation. So I'm going to go to Help, Statistics Index. The statistics index is much like the index of a book, where in a book, we see a list of all the key terms or topics in the book and page numbers so that we can find more information about each one. In the statistics index, we have a list of all the statistics produced in JMP, along with some helpful information. For example, here we have a definition of the, in this case, 3D biplot. And we have some buttons down below that will take us to, from left to right, the help documentation online, to a launch window where we can actually run this analysis on our own data. Or on the right, we see we can run an example, which will actually run this JSL code that's editable down below to kind of show us how the analysis works on some data that's built into JMP. So we know that we want a one sample t-test. Let's scroll down in the list of statistics and analyses to find what we're looking for. Once we get down to O here, you can see we have our one sample t-test. I click here and see that this is a test that the mean is some hypothesized value. That's what I want. I want to see if my download speed might be different from 100 megabits per second. To get more information, I'll click the Topic Help button. This launches the help documentation in my web browser. I can see that we're going to be using JMP's test mean capability with more description below. And if I scroll up to the breadcrumb at the top, I can see that this is under the distribution platform. So now I know where to find this. I'm looking for the test mean option in the distribution platform. I want to see how this works, so I'm going to go ahead and run the example built in. When I click on the run example, JMP opens a sample data set, in this case, the big class data set, which contains information like age, sex, height, and weight of 40 students from ages 12 to 17. We can see in the analysis window that it's pulled up, we have a one sample t-test down at the bottom, where we've tested the student's height against a hypothesized value of 61. So this looks great. This is exactly what I want to do. Let's actually run it on my own data. Close these windows down, and now I'll click Launch. Tell JMP that I want to analyze my download speed. Click OK. Enter the hypothesized value of 100 megabits per second. Now JMP has performed the analysis on my data set. And if we have a look below, we can see that I have a statistically significant result indicated with the orange p-values there. So it does look like I have real evidence here that I'm getting a few extra megabits per second than what the internet service provider has promised me. So that's pretty great. Now, if I want to run this in the future, I could, of course, return to the statistics index and click Launch, but luckily, by having already studied the topic help and viewed the example, I actually know where this lives. In fact, the whole time, it has been living in the distribution tool that I was using at the beginning. So in the future, anytime I want this analysis, I now know that I can find it as the test mean option in the distribution platform. So that's it for help today. This is the Statistics Index, a one-stop shop for all of these statistics in JMP, where to find them and how to use them. So we'll continue with some more JMP On Air programming. Julian, back to you.
Thanks so much, Ross. And yeah, very, very helpful. If any of you have suggestions for help in the future, you can also leave Ross a comment on the help page in the JMP community. We're a teeny bit ahead of schedule, so I'm going to put in a 2-minute break for us right now. If you want to run to the kitchen, grab that snack that I know we've all been grabbing every 10 minutes for ourselves anyway, go ahead and do that, and we'll be back in just 2 minutes. Hello and welcome back. So in our next segment, we're going to hear from a JMP developer. And this is an ongoing series where we're going to bring you JMP developers really every week to meet. What I think is really special about this series is that I think many of you have probably used the platforms of the JMP developers we're going to feature. And what I love about this is we get to show you some of the people that actually are spending their time designing these platforms. And I think once you know the people a little bit better, you may even know the platforms a little bit better, because the way JMP works is obviously a reflection of the way our developers think. So I'm very excited for the first episode of Meet a JMP Developer.
I'm very excited to interview our research statistician, Laura Castro-Schilo, who works on some very cool statistical capabilities in JMP. So Laura, welcome.
Thank you. It's nice to see you.
You too. Before we jump into the questions, since I've been working from home and you're relatively new at it, how's that going?
You know, it's a little bit challenging. We have 2 young girls and a puppy, and you know, it's just sort of juggling what I'm sure is the case for so many other people. But it's also been fun, I guess, because despite the challenges, you know, we're spending that much more time together, which is nice.
Nice. A lot of people seem to be getting puppies, taking advantage of the time that they're at home. How old is yours?
Yes, 14 weeks.
Oh, good.
Yeah.
Nice.
It's been really fun. It's been a great distraction, and actually, yeah, just, you know, there's not that much more time anymore to kind of keep up with the news as much as before. And so there's definitely a lot of just healthy repercussions from
pet therapy.
Yes, exactly.
Awesome. Well, first, tell us, where did you grow up?
Well, I grew up in Mexico. Guadalajara is the city where I spent up until I was 18. That's where I was at. So even though I was born in Mexico City, but when I was 4 years old, my parents moved to Guadalajara, and so that's where I grew up.
Nice.
Yeah.
I love your accent. It's very, very faint, but it's lovely. Well, where did you go to school and what did you study?
So I started in a community college, actually, in Southern California, Orange Coast College. And at the time, I was very interested in audiovisual arts, and I was a film major.
Oh.
And so I really loved audiovisual arts. I still do. And so I experimented with a few classes at that community college. But then eventually I took a psychology class. I was very interested, continue to be in psychology. And so I ended up changing to a psychology major. And then I continued on to, after getting my AA at community college, I went to Cal State Fullerton in Southern California. And that's where I got my BA in psychology.
Okay. And then you continued on to get your PhD.
I did, yes. So I love psychology. I was very interested in personality and emotions. And as it turns out, as I was working on research with professors, statistics was obviously involved all along the way. And when you're trying to understand human behavior, measuring the things you want to study is very, very difficult. And so I started getting into statistics, and it actually was fairly late in my psychology career that I realized there was a quantitative psychology field. And so one of my mentors at Cal State Fullerton, Dr. Stephen Miller, he suggested that I look into quantitative psychology programs because I had only been looking into social personality programs. And so, yes, so I was fascinated by the fact that this field existed because I love psychology and I love math and statistics. And so I went to UC Davis, which is where I found, where I got my PhD.
Nice. It's fascinating. I think our brains are one of the last frontiers to further understand.
That's right. And the field of psychology is so vast. I mean, there are so many things that one can study. And I think that was also very appealing to me. Okay, so if we're going to learn about the statistics that are applied for psychological research, there's really so many domains within psychology that you can use statistics in a very clever way. I actually specialized in longitudinal modeling, and so I worked a lot with developmental psychologists looking at children's trajectories over time, or elder adults, and looking at cognitive development, or it was, they're very interesting to me. So the statistics required for doing all of that can also be very challenging and interesting.
Yes, of course, and powerful.
Yeah.
Well, I'm curious, where did you work before you came to JMP?
So after I finished my PhD, I actually got a tenure track position at the University of North Carolina in Chapel Hill, which is what brought me to North Carolina. So we're at UC Davis, and so I came to Chapel Hill. This was still where I'm at today, and I was at UNC for 3 years. It was really interesting work, very, very demanding in terms of, juggling research and teaching and committee work. But it was fun. I enjoyed it. I learned a lot, but it was definitely tough to do. I had a 3 and a 5-year-old at the time, and I just, I figured it, I needed something different. And so I moved on from academia. Yes.
Made that transition. Well, we're so lucky to have you, and glad that you did make that transition. Well, for our viewers, tell us how long you've been at JMP.
Yeah, it's going to be 4 years this July 1st.
Wow.
And yeah, time has flown by. Of course, around JMP, I'm still pretty new. Everyone's been here for such a long time, being such a great place to work at.
Indeed.
But it is now almost 4 years.
That's great. Well, why don't you tell us about what you've been working on in those past 4 years, because it is pretty exciting.
Yes, I feel I've been so fortunate to really find just a very nice fit for the skill set that I have and the needs at JMP. When I first started, I was working with the testing team, and I was involved in a number of the multivariate platforms, exploratory factor analysis, principal components, multiple factor analysis came afterward. And so it was really fun. I mean, I've always really loved the testing role is quite, I always described it as being a stats detective. You're trying to figure out, okay, when do things go wrong and why do they go wrong if they do? And so it was really fun. And then I moved on to the development position that I have, and this is where I been working on structural equations models, a new platform that we just released in JMP Pro in version 15. And I was just thinking, it's almost 2 years since we started working on that, and it's just it's been fascinating. It's a dream. It's the statistical technique that I'm most passionate about, that I think is very, very useful for those who whose research needs or analytic needs are well fitting with this platform. And so it's just been a lot of fun. I've worked with great people who have come together in making the platform a really great option.
And I think you've made a lot of users really happy, because this has been a much anticipated functionality.
Yeah, I think there are. Yeah, I've heard from a few people who said, "Oh, we were waiting for this to come."
Yes.
For several years, and so I do think it's really fun to get that positive feedback. And we got incredibly lucky too that we just have such talented people at JMP. One of them, Eric Russo, came a little bit later into the project and was able to really make wonders with our path diagrams for the platform. And thanks to all of the work that he's done, and of course there's other folks who've contributed a lot, but thanks to that, I feel so proud to be able to say that legitimately believe we have the best path diagram and the best features for building these diagrams in our software. So it's amazing.
Awesome. Well, why don't you share with us what kinds of problems structural equation models can be used to solve, and more on that.
Sure. Well, interesting thing is that it's such a flexible framework. It's not just one statistical technique as much as it's just a framework where a number of different models can be fit. Sometimes I tell people, it's sort of the merging of factor analysis and regression analysis, but regression on steroids, because you can really do so much. And what I mean by that is, any given variable in SEM, in this platform, can be both a predictor and an outcome, which means that you can really use this platform to understand the mechanisms by which things happen. So if a variable is a predictor for another, but then in turn that other variable also predicts a third variable. And so variables can have both roles of predictors and outcomes, which is very unique in terms of the way we think about statistical techniques. Another very important use for the platform is that it enables us to measure variables that we do not observe directly. And this is why it's something that we use so much in psychological research, is because just about everything we're trying to understand are things that we don't have a specific, observable variable for. And so the way that's where factor analysis comes into play is that latent variables can be modeled by leveraging the things that we do observe and using those to model the unobserved variable.
Right.
And so, anytime people have similar scenarios where they're trying to capture something they don't observe directly, this is a very useful technique. Or simply if they have measurement error in their variables, which just about everyone I think does have.
Yes.
The platform provides a framework to enable to account for that measurement error. So giving you better predictions and better, estimates for your models.
Right. Well, do you have an example that you can share with us or show us?
Sure. Yes, definitely. Let's see. I'm going to share my screen. Can you see my screen now?
Yes. Great. Thanks.
Great. So yeah, I had a data set here. I called it, consumer data. These data are simulated, but I figured they're simulated in a way that I think can resonate with many folks out there. Structural equation models can be used with all kinds of data, but very commonly we might have surveys where questions are asked of people, and the answers to those questions can then be collected in a data table like this. Here, because this is an example of the person's perceptions of an online website, and so they tell us about perceptions of privacy, reputation, security, trust on the website, and then they also report somewhere further down purchase intentions. That's what these variables represent. And so we can use, if I go here to analyze multivariate methods, we have our structural equation models platform. And we can use the platform first to investigate the validity of the questions we're asking in that survey. We might be asking questions about privacy, and we want to know whether those are in fact good questions. Are we really getting a good measure of the perceptions of privacy of this online website? And the same for the other constructs. And so I'm going to select all of these variables, model variables, and click OK. And we go here to our structural equation models platform. And notice we have this really great diagram here. Something very powerful and unique of SEM is that these path diagrams map directly onto statistical models as long as they're drawn correctly. And so what you see here is a model in which every single variable that I submitted for modeling has these double-headed arrows which represent the variance. All right, so we have that variable and we are acknowledging that there is variability in that variable. But we can now have this sort of canvas to specify a model. Let's start, for example, I might just call this a survey validation model. And this is validation in terms of looking at the validity of the survey. Does it really measure what we think it measures or it should be measuring? And so what I'm going to do here is I'm going to get all of the items, all of the questions that are related to privacy. And if I select all of them, I'm going to leverage those questions to specify a latent variable that I will call privacy. So I'm going to click add latent, and this is the path diagram that represents a latent variable. And so we're now leveraging the information in all of these 4 questions, the answers that survey respondents provided, to measure the common variance across all of these answers. And now we can call that privacy. So this right here, the circle, is the latent variable. And we can do the same for the other variables. We have reputation. And so I can call it reputation and add a latent variable. And we'll keep on doing that with trust. And add another latent variable. And we have security. Let's see. And lastly, we have purchase intentions. I'll just call it PI. So we're using all of those variables that we do observe to capture these latent variables. Oh, look at this. At the security one, I did not give it I went with the default latent variable name. So
that's okay. We'll keep track.
All right. For now, that's what we have. All right. So we can use these from and to lists to select those latent variables, and we can make sure that they all co-vary with each other. And this might be one model that we can run. And you see, we get estimates for, all of the loadings of the factors. Perhaps I want to show standardized estimates. And so I can see the loadings, and these are loadings interpreted just like they would be in a standard factor analysis way, meaning that this is the correlation of this specific observed variable with the unobserved latent variable. And we get a sense this way of which might be good or bad indicators of our measure. Right here, all of these loadings are fairly good correlation sizes. The lowest one is about 0.54, so that's not too bad. This means that these variables, these questions in the survey, are in fact, they do have a lot of variance in common amongst them, and they do seem to represent, to capture this latent variable of perceptions of privacy. But as we look at other latent variables, we might find others that aren't so good. Like here, we had this reputation question, and its loading is about 0.4. There are some rules of thumbs out there that 0.4 or higher is good, but we might think, okay, do we really need this question? Or we might go back and look at the question itself to see if there's something we can do to reword it so that we can capture reputation a little better. And so on and so forth. So this is an example where we can use structural equations models to look at survey data. And once we have a good set of items that are capturing our latent variables, we might want to fit an actual model that tells us how is it that purchase intention comes to be. Is the privacy, the reputation, and the trust on the website really critical for predicting purchase intentions? And so we can do that sort of thing. We can, I can go back here. I have a list view, so we can look at a diagram, but we could also look at lists of all of the edges in the diagram. And I might just, get rid of all these covariances. I'm going to remove them. And I might just say that, maybe privacy, reputation, trust, maybe all of those are really predictors of security. Remember, this latent one is security. So I might just say, these are all predictors of security. and is security that then predicts purchase intention perhaps. And I have to have covariances amongst these variables, something like that.
Mm-hmm.
So now this is a very specific theory, right? Now I'm saying that the way in which purchase intention, in which people intend to purchase a product is because they perceive, perhaps high privacy, trust, and reputation of the website, which then leads to them feeling more secure about the website, which ultimately then increases perhaps the likelihood to purchase something. So we're being able now to test very complex and very specific theories in this platform. And briefly, I know we don't have a bunch of time here, but I just want to say that something that's very unique as well about our platform is that we have this status tab that gives us all sorts of information about the model that we are looking at currently. And this can be very, very helpful because even though SEM can look very intuitive because we have these nice looking diagrams, there's definitely a learning curve for knowing how to fit these models and specify them correctly. And so this status tab gives us a bunch of feedback on our model specification. In case we make a mistake, we know that we need to fix it, right? So here, perhaps I might, if I free that estimate, okay, notice the status tab just changed. I used to have this represented a parameter that was fixed to 1, and that was done by default. It's important in order to identify a latent variable, we need certain constraints. But not everybody might know that. And the moment I removed that constraint, that status tab gave us this feedback immediately so that, hey, something is not right. And therefore you can come here and figure out what is it that's not working well. Oh, well, you don't have a scale set for your latent variable. And so you get a little bit of feedback here to know how to fix that problem. And of course, once we fix that, we then get our status back to, good check mark.
Nice.
Yeah, so we have a lot of feedback that we provide through this tab, and you get that feedback right away. As soon as you make any sort of mistake or there's something, that's not quite right, you'll learn about it right away. And I think that can be very helpful for all users.
Yes, very nice. And those are great path diagrams. I agree. Very clean.
Yes, and I wish we had more time just to talk about how many things we can customize here. We can change the size of our variables. We can change their colors. If there's folks out there who really like all their, colorful stuff, you can definitely change the way all of these.
Nice.
Yeah, and everything is very, very interactive, very user-friendly. So yeah, I encourage people to take a look at this.
Well, what is it like for you to write code and then see other people using the thing that you built?
It's a great question. I mean, it's so rewarding. To me, what's most important is to make things really accessible for anyone who's motivated to learn about a technique.
Yeah.
And to me, what we've been able to accomplish here is a user-friendly interface it's not just about user friendliness, but it's also very effective. Even if you're an expert and can write code, you might still want to use this because it makes your model fitting that much faster, right?
Yes.
And so I think just being able to provide something that's useful to people and then hear the feedback when they say, oh my gosh, this is so useful.
Right.
I've heard folks who say, oh, you can accumulate all of your models in one place, like this model comparison table here. You can see how all of your models are fitting all in one place. And people have already told me how useful and time-saving this would be. And so it is very, very rewarding. I love it.
I can just imagine, and I'm so glad. So you deserve it because good work.
Oh, thank you.
Well, tell us something that you're passionate about that's non-statistical or not related to JMP.
Well, I think I'm actually very passionate about just new experiences. I love to travel. I love to try new foods. I like to even in my own community, I love to go places where I haven't been before and just sort of get lost, and figure it out where I'm at. I love, different languages. I really enjoy just new experiences.
You're an adventurer.
I am. Yes. I really do think it's fun. It's
good.
Accumulating experiences in life is fun.
Agree. Makes it richer. Well, I wish we had more time. It has flown by, but thank you so much, Laura, for sharing with us. This has been great.
My pleasure. It's nice chatting.
Take care.
Bye.
Fantastic. Well, thank you so much, Laura, and thank you so much, Anne, for interviewing Laura this time. Definitely tune in every Monday for another JMP developer that we'll get to meet and hear about the platforms they make and their amazing contributions to our amazing software. In our next segment, we're going to hear about something maybe a little bit less complicated than structural equation models, and that's how to add text hyperlinks into JMP data tables. And we're going to hear about it in our next segment of Have You Tried?
You can now define a text column as a column of hyperlinks using the event handler column property. For example, you can create a column of geographical data as links to a Google map or include links to Wikipedia pages. The quickest way to see this in action is to open up the SAS Office's JMP sample data table accessed from the Help menu in JMP 14. After right-clicking the city column and selecting column info, notice that the event handler column property has already been added. What makes the event handler powerful and handy is once you set up this column property, you don't have to customize it for each link for each unique row. It applies the link structure to the entire column and concatenates or joins it with each unique row of data, creating a custom string. In this example, the first column in the data table links the country to Wikipedia, and the fifth column uses the event handler to link that city to Google Maps. So I'll create a sixth column and link all of the cities to Wikipedia because we do not have that linked yet. I'll double-click a blank column header to create a new column. I'll then select the cities column and copy these cities, edit copy, and then edit paste into my new Wiki City column. Notice the row values don't have hyperlinks yet. To add those, I'll double-click again to bring up the column info. I'll rename the column to City Wiki Info. Then I'll set the data type to character. Then under column properties, select event handler. It's in this event handler script is where I'll add the wiki URL or your custom URL. I'll paste the wiki URL in the first part of the web function in quotes. And then I'll concat or join this to the remainder of the script with the two vertical concat lines. Now I'll select apply and OK. Now by selecting the cities in this new column, it launches unique wiki pages for that row of data. Follow the links below to learn more about hyperlinking to even internal files on your computer. I hope you find hyperlinking helpful in all of your JMP projects.
Fantastic. Thank you so much, Ryan. Yeah, there's lots of applications we've seen of people using hyperlinks within their data tables, and so it's really a great thing to explore. And I'll just add that the event handler can be generalized to do lots of different things. So it's a real general purpose way to utilize cell values and take some operation on them. So certainly worth exploring, and you could even go to the JMP help, search for event handler, and read more. So many of you know that JMP is very good at design of experiments, but maybe some of you have been asking yourself, why should we design experiments? In this next series, Phil Kay is going to tell us about why DOE. Why should we be designing experiments?
Hello there. So unfortunately my webcam's not working. You'll have to make do with this little picture of me. So I started writing a series of posts more than nearly 2 years ago now about design of experiments. And I want to tell you in this episode why I started doing that. And I'm also going to answer some other of your questions, or rather my questions. So we'll talk about why I wrote this blog series. There is a case study throughout this series that I've used that I was very lucky to be able to use. And I want to tell you about that so that we understand the engineering challenge, the science challenge that we're trying to solve in this example. Now that's a very specific case study. It's actually around using something called a large volume injector in gas chromatography mass spectrometry. I'm guessing most of you aren't involved in that kind of situation. So we need to talk about why this applies in any science and engineering challenge that you might have where you need to experiment. One of the reasons I wrote this blog series is because I thought there was a way of motivating you to become interested in design of experiments. And that is to think about the sheer number of possibilities when you're experimenting on a process or system. So in this week's episode, you're going to see, using our case study example, just how overwhelming the number of possibilities can be when you start to consider how you're going to experiment to optimize or understand a process or system. And I'll tell you also about what we're going to learn about in the next week. So why did I write this blog series? Well, I really love design of experiments. I love it because I hate to see people wasting time. And scientists and engineers, if they're experimenting on a process or system and they're not using smart ways of doing that, if they're not using designed experiments, then they're almost certainly wasting a lot of time. They're also missing the opportunity to really learn about their process or system. They're also missing the opportunity to really show people what's possible with science and technology. Another motivation for me is that one person once told me that he thought design of experiments was almost like a religion. You had to have faith in it. You had to be one of the believers, one of the disciples in order to have some success with it. And I think, that I found that quite funny actually. Partly because I think there's an element of truth in it. I do think that people get very passionate about it. And it can seem kind of magical because it's so powerful. I want to demystify it so that it doesn't seem magical. Another challenge I think you've got with design of experiments is there's a lot of terminology, a lot of lingo, a lot of jargon. So we need to talk through that. We need to get past that. So we need to explain some of the terminology so that it becomes more accessible to everybody. I don't think it has to be difficult. I don't think you have to have an advanced degree in mathematics in order to understand it. In fact, I don't think we need to talk much about mathematics at all to understand why you should be motivated to use design of experiments. And as I mentioned before, it just happened at this time that I got my hands on a really great case study that I thought would be really nice example to share, to be able to explain the motivations for design of experiments. Okay, so if we're going to understand all of this, we need to understand what the case study is. And hopefully it's fairly accessible to you all. It's about something that is extremely important to all of us, and that is water, and about water quality. Now, in order to ensure good water quality, a lot of people are working to check the water quality by taking samples around the place and working out what's in that water. most water is not going to be 100% pure. And if it's from the outside world, then it could be contaminated by various pesticides and other chemicals that can leach into the water system. So it's really important to have a good way of quantifying what impurities there are in the water. This is done by analytical chemists, and they take these samples and they use methods like gas chromatography, mass spectrometry, in order to measure all the different substances that are in there, to quantify how much of them are in there and see whether they're within safe limits. This can be quite a challenging thing to do. These chemicals are not often there in very high quantities, in very high concentrations. So you need to have very good methods in order to detect low levels of these potentially dangerous contaminants in the water. So I'm lucky to be working from home at the moment, and my children are also studying from home, so I've got access to their beautiful colored pens. So I've drawn this technical diagram of the process we're talking about here. So what we need to do, the challenge is, how do we make sure that our measurement of contaminants in water is as good as it possibly can be, so that we can detect the lowest possible levels of these contaminants? What we're going to do to ensure that, to solve this problem, is we'll take a standard sample. So this is a made-up sample of water with known levels of these contaminants in it, some standard kind of contaminants that have been loaded into it. And we're going to run that through a gas chromatogram mass spectrometer. And that results in these chromatograms. We get these pictures out at the end, essentially. And a good one looks something like this, where we have very big peaks. Each peak corresponds to a different substance. And the height of that peak relates to the level of that substance in the sample. So when we run the standard sample, what we want to see are the highest possible peaks, and we want them to be very clean and symmetrical. What we don't want to see is the picture there in red, where we just see very small peaks. They're very, not very clear, they're very unsymmetrical. One of the ways that we can influence it to achieve the best possible chromatograms, these sharp, tall peaks, is using something called a large volume injector. This is just a look at a real chromatogram. So this is quite a good one here. You can see some strong, sharp peaks, which means we can quantify the contaminants in the water sample very readily. Okay, so then I've elaborated a bit. I don't really know how these large volume injectors work. This is just a schematic of it. So what we do is we inject some of the sample into the large volume injector. And what it's going to do is concentrate up the sample by drawing off solvent from it. Now, what's a challenge here is that we don't just plug the large volume injector in and run it. There are lots of different things that we can change. So we can change the volume that we inject, the injection volume. We can change how fast we inject that into the large volume injector. We can heat the volume that we're going to inject. We can heat that or cool it. So it could be between -30 degrees C or up to +30 degrees C. We can change the depth of injection. We can change things about the venting process, the flow, the pressure, the time. And there are liners within this large volume injector as well. And there's at least 2 different types of liners that we could look at. So the challenge is to understand what settings are going to give us the best possible chromatograms, give us these strong peaks so that we can detect very low volumes of the contaminants in a water sample. How are we going to figure this out? Well, we can use, to some extent, theoretical understanding. We can go to a textbook. We can go to the manufacturer's recommended advice. But the scientists that work on this tell me that actually it's really difficult from when you first just receive a sample. It's really difficult to know what settings are going to work well for a given sample, for a given types of chemistry. Often when they ultimately find the best settings, they're very different from what they might have expected. So the only way really to work out what are the best settings is through experimentation. We actually have to try some different things here. So we actually have to inject some of our standard sample and try that at different settings. So we'll set the injection volume and the injection temperature and everything else to certain settings, run a sample through, and then see what the result is. It's essentially trial and error, or trial and improvement. So that's the case study that we're looking at. Basically, our challenge is we need to understand how do we change these different settings in order to give us the best measurement of contaminants in water. So I'd be amazed if any of you are actually have that specific challenge. Please let me know if you do, it'd be great to hear. I suspect that you're all, though, working in science and engineering in some way, or in some other situation where you need to experiment, where you need to understand your processes or systems. And this is a very specific example, but there's nothing special about it that means DOE is uniquely useful, as I point out in this first poster of this series. Design of experiments is going to be useful in any situation like this, where there are lots of things that you could change, and the only way of understanding what the best way to set these things up is through experimentation. So these are the factors we've got in this case. We have 8 things that we can change. We can change the injection volume, injection speed, injection temperature, depth, vent flow, vent pressure, vent time, liner type. So whatever your situation is, just think about that in terms of factors. So these are what we call factors in design of experiments. These are the things we can change. Why should you be interested in design of experiments? So if you've got a situation like this where you need to understand the impact of changing all these factors, I'm going to show you why you should be interested in design of experiments. And really what it comes down to is that when you're in this kind of situation, when you think about it, there are really just an overwhelming number of possibilities, and you couldn't possibly experiment and try them all. And so this is why design of experiments is going to be useful. And I'll go into JMP here for a little demo. So what I've actually got here is a table with more than 4,000 rows. Each of these is what we would call a run in an experiment. So each of one of these is with a different setting of the factors, the volume of injection, the speed of injection, and so on. And what I want to show you is just the sheer number of possibilities. So let's consider volume of injection. Just putting that on the y-axis here. It's very sensible to experiment on 3 levels. So we've got our range of injection volume. So we could experiment anywhere between 10 and 100 milliliters per minute, I think the units are. So we want to understand which of those gives us the best results, which of those gives us the sharpest, highest peaks in our chromatogram. Well, that's just one factor. We could try those 3 different settings and keep everything else the same and see what we get, and see if we can learn about the impact of volume of injection. There are 7 other factors to consider as well. So let's look at speed of injection. Let's put that on the x-axis. And we can see there are 9 different combinations. If we're also going to experiment with speed on 3 different levels, so we've got speeds of from 0.25 up to 5, and with a midpoint of 2.625. Well, now there are 9 different possible combinations, 9 different possibilities. And if we tried those different settings, ran our standard sample through at those different settings, and looked at the chromatograms at the end of it, then, well, we could probably learn quite a lot. We could learn a lot about the volume of injection and the effect that has on the chromatogram, and learn about how speed of injection affects the chromatogram. There are still 6 other factors. So let's look at temperature of injection. Well, now there are, for every different setting of injection temperature, and we've got 3 settings that we'd like to try there, there are 9 different settings of volume of injection and speed of injection combined. So we've got 27 different combinations in total. Well, let's add depth of injection. So now we've got 3 times 27, 81. Let's add flow vent settings. Well, now we've got 243 different settings, and so on. I'm going to add 2 other factors, and finally liner type as well. Let's add that as another factor. Now let's just color that. And I've done this before, so let's maximize that now. So it turns out that if we wanted to try each of our factors at 3 different settings, the lowest, the medium, and the highest, there would be 4,374 different combinations. And that's with liner type. There's only 2 different possibilities there. It's a categorical factor in this case, we would say. It's either type 1 or type 2. There isn't a midpoint between them. It's just one or the other. So there are 4,374 different ways that we could set up this large volume injector. And we're trying to find out which out of those is the best one. This is just an overwhelming problem. It's an overwhelming amount of work. We can automate this system. It's one of the nice things about this case study. We can actually automate it so that we don't have to manually change the settings ourselves every time we do it. Even then, it's still an overwhelming amount of work that we couldn't possibly do. So think about whatever your process or system is. Think about all the factors that you could change, and then think about the sheer number of possibilities that there are out there for how you could set up your process or your system, your measurement process, whatever it might be. What we're going to cover in the next session, and throughout this case study, is we're going to see how actually we don't need to test all of these possibilities. It's not necessary to try all of the different possibilities. In actual fact, I'll be showing you how out of these 4,374 possibilities, there are 26 that we could try. We'll go and set the large volume injector to those different settings. We'll run our standard sample through it. We'll look at the chromatograms, and from that, we're going to be able to learn how to optimize this system, how to optimize the settings of the large volume injector to give us the best possible measurement process. So before I go, I wanted to point out, I'd written a LinkedIn article as well about why we experiment, because I think if we're going to understand about why we design experiments, it's a good idea to think about why we experiment at all. So if you want to have a read of that, just look me up on LinkedIn, connect with me. It'd be great to talk to you and answer any questions. If you've got any questions about today's episode, then go to the JMP community, find my blog post, Why Design Experiments, reason number 1, and you can ask any questions within the community there, and I'll be very happy to answer them. As I say, next week we're going to be talking about process understanding. So we're going to be delving more into why these 26 different possibilities are such a powerful choice for us to be able to learn how to optimize this system. And we're going to be looking at how models of our process that we build from data give us the best possible science and engineering solutions. with that, I'll hand it back to Julian for the rest of the broadcast.
Thank you so much, Phil. You ended with 7 seconds to spare. I think that's the closest of anyone yet. Thank you so much for taking the time to talk with us, and I hope everyone joins us next week when you actually take us through that definitive screening design. I'm really excited to see that. Again, all the links that Phil mentioned will be on his page from today's episode, and you'll be directed there just after the episode. I'll even mention at the end again how to get there if you want to find it on your own. So our next segment is a fun new one that we haven't shown before. It's DIY data, and Ryan's going to take us through some of the things he's been doing it himself.
Hey guys, welcome to DIY Data, a show where we do cool things with everyday data. A JMP colleague of mine wrote up of an innovative way to read real-time data with an Arduino. That's a small microcomputer. I wanted to try this for myself, and with the help of my colleague Stan, we made a few adjustments with the current version of JMP, and I'm happy to say it was successful and was sincerely a fun project to work on and experiment, and I learned a ton more of JSL. The JMP script and Arduino code are both linked below for you to experiment. This video is not a comprehensive tutorial on how to write Arduino code. That's the code that lives on this little microcomputer. But it serves as an introduction to connecting sensors into JMP using JSL. So an Arduino is an inexpensive microcomputer that comes in different sizes, even smaller than that. It connects through USB, and you can upload your custom code for it to run. It can operate on a battery or use the power of a USB, like a weather station. I'm using an Arduino Uno R3, and I've connected a light IR sensor, that's something that senses light, to pin 0, and I will get power from the USB attachment to my computer running JMP. The case around it protects the Arduino from everything and allows you to add and experiment with additional sensors without removing the case. So this is optional, but it makes it a nice experiment project. First, let me show you everything working with the code, and then we'll go into a few more details. With that attached script below in JMP, I'll select the Run Script icon and the top ribbon banner. That will first create a data table with 3 columns. Additionally, 4 scripts are waiting in our table panel now. In my table panel, I'll select Run Connect, and it will open the communication port that the Arduino is on and start the main script going. So we have 2 different things going on in the computer, JMP and the Arduino connection. By the way, I'm virtually running Windows on my MacBook Pro, and my Arduino is on COM3 because that's what the drop-down connection port said in the Arduino software. When you plug in your Arduino, it connects to a COM port. As you can see, it quickly starts populating our first column with the light data, with the IR sensor connected to my Arduino. The second column is a timestamp created by JMP. It also launches a control chart builder for us to visualize the data in real time. That's got to be one of my favorite things about this project. Here's a high-level description of how it works. The Arduino is powered up and actively collecting sensor information using the uploaded code linked to this video. So we upload code to the Arduino. So when we power it, it's running that code. In JMP, the JSL script creates a data table with 2 columns, sense and time. The baud rate is quite high, but that's just one way I've found not to miss any data from the Arduino feed. The JSL script makes the connect script, which connects and listens to the port the Arduino is using. We start the time, grab a line from the feed, end the time, then populate the data table row for sense and time. Next, we launch a control chart builder to visualize the incoming data. This portion loops until we run the script to disconnect. That's in the tables panel. You could potentially add any sensor to the Arduino you would like, including reading from the digital pins. In an upcoming video, I plan to make a mobile version of this using a touchpad. There are industry-grade Arduinos out there for controlling most automation purposes, so you might want to check that out. I'll let you discover those with an internet search. If you have any questions or ideas, please comment below this video, and we look forward to hearing them. If you have any ideas for DIY data, if you'd like me to experiment with anything, data that you use on an everyday basis, let us know below, and thank you for watching DIY Data.
Great. Thank you so much, Ryan. You can tell which person among all of us is the digital designer. Thank you so much. We'll certainly put your suggestions in for Ryan to do other DIY datas. On the episode page, you'll have the opportunity to post, whatever ideas you have. And I can't wait to see what else Ryan comes up with. In our next section, we're going to learn about a really cool feature within JMP 15, and that's how to create drill down graphs using Graph Builder. And so I want to turn it over to Wendy, who's going to take us through how to do this.
All right. Hello, everyone. My name is Wendy Sang, and I am the technical lead for North Central. And I'm excited to show you how you can create drill down graphs in JMP, which is a new feature in JMP 15. First, this guy, since we're going to be utilizing some brewery data, I thought I would show you where is North Central. North Central encompasses these states in basically the middle of the US. And I support this geography along with my two teammates, Andy Spence and Kathleen Watts. I also wanted to highlight to you some of our favorite breweries in the Minneapolis area. So if you ever come by, please check these out. All right, now let's go take a look at the drill down graph that we're going to create together. This drill down graph will allow us and others that we share this data table with to explore brewery trends in the US. I'm going to hover over the state of Minnesota, and you can see that I can drill into Minnesota, and I can see what the average annual production volume by type and how that breaks out. And then I can also do another drill in where I'm hovering over production volume produced for brewery consumption, and I can see a trend of what that looked like over the last several years. All right, let's see how we can build this together. So we're going to build this using Graph Builder. And the way that we're going to do this is we're going to build each one of the 3 layers individually, and then we will nest the scripts within each other, kind of like a Russian doll. So let's go ahead and build that first layer. So the first layer that we looked at was a map of the US. So I'm dragging state into the map zone, which brings up a shape of each state. And then I'm dragging volume.
Wendy, not to interrupt you, I don't know if you're sharing anymore.
Oh no. See. How does that look?
Perfect.
Okay, when did I stop sharing?
Oh, just a little bit before there. You're fine.
Okay. So now I've got a map of the US, and each state is colored by the volume of beer in barrels. Because I have a lot of states with some of these lower volumes, to create some differentiation in the map, I'm going to change the gradient scale to be quantile instead of linear. All right, So that's layer 1. Now let's go build layer 2. I'm going to open up Graph Builder again. And layer 2, right, we looked at the breakout of the volume by type. So I'm dragging type to the x-axis and volume to the y-axis. And since I want a bar graph, I'm going to change this visualization to a bar. The next thing I want to do is to order these bars in descending order. So I'm right-clicking on the x-axis and doing order by volume descending, which gives me a nice sort. So that is layer 2. Now let's build the final layer. So again, I'm going to open up another instance of Graph Builder, and I'm going to build that trend graph. So I have volume, which is on the Y, by the year. And I'm going to change, I'm going to overlay by state so that we have a separate line for each state. And then I'm going to change this graph type to a line graph. And one nice thing to do in this particular case is to get rid of the legend on the right. So I'm going to go to the red hotspot and uncheck legend and click done. Okay, so now we've built the 3 layers. And what we're going to do is nest them within each other. So I'm going to grab the code that creates this particular graph. So I'm going to start with the 3rd layer and nest within the 2nd, and then take the 2nd and nest within the 1st. So I'm going down to Save Script, Copy to Clipboard. I'm going to go to the 2nd layer, and I can essentially right-click on any one of these graphs or these bars, go to Hover Label, and paste Graphlet. Once I do that, I hover over one of these bars and I can see that I'm getting a graph. Now our 3rd and last step of nesting is to take this particular script and copy it and then paste it into the 1st layer. So again, I can right-click anywhere in this graph, go to Hover Label, and say Paste Graphlet. And now we can test this. So if I hover over the state of Colorado, for example, I can drill into Colorado, and I see that brewery production for brewery bar is pretty low in this state over the last 12 years. If I hover over bottles and cans, I can click in there and see the production volume trends over the last 12 years for Colorado. So our last step really is to save this to the data table. So I'm going to go to that 1st layer, and I'm going to go all the way to the bottom and save script to the data table. We can call this brewery trend drill down. And now, if I were to save this data table and send it to someone, they could also explore this data using the drill downs I've created. So I thought I might take go backwards a little bit and talk about where I got this data. So I got this data from our Department of Treasury. And because the federal government taxes our states based on how much beer they brew, you can go to this website, and it's all recorded here. And the government records how much production by state there's been for consumption on premises, consumption in bottles and cans, and then finally barrels and kegs. So this is where I grabbed the data and I actually imported it into JMP using the PDF document because there's a PDF import wizard in JMP. And then I reshaped the data. So if you look at the number of rows I have in this data table, I've got 1,800 rows. So it's a very tall data set. I had to take the years that went across in the columns and stack them. So there are 36 rows for each state in this data table. And this allows me to do the various drill downs ending in that trend graph that I had. So I have 12 years and I have 3 types per year, which gives me the 36 rows per state. So hopefully you found this helpful and are eager to try this with your own data. I encourage you to look at the post following this presentation and take a look at this blog post that our founder wrote, which will give you a little bit more information about creating graph drill downs and customizing graphs further. Julian, I'll send it back to you.
Fantastic. Thank you so much, Wendy. I love those graph drill downs, and you make it look so easy. And I'm so pleased that JMP, really lets you customize those graphs and really do that for any situation. So do check out that post that Wendy pointed out to. It'll certainly be available in the page that is linked after we redirect you after the episode. And yeah, we hope you try it in your own data. All right, our next segment is going to be Tip of the Day. We have Mary and Pete back with us to tell us about creating summary statistic tables using Tabulate.
Thanks, Julian. Yeah, today Mary and I are going to go over one of our favorite platforms that's a little bit underappreciated, Tabulate. So Mary, you want to take it away?
Sure. Hey, Pete, how are you today?
I'm good, all things considered. How about yourself?
I'm doing all right. I'm doing all right. So you sent me some email. You want to learn about how to create tabulated descriptive statistics tables, huh?
Yeah, can we
That was a
look
mouthful.
That's right. Can we look at all 3 of those outputs and get some statistics on them?
Yeah. Well, you get me all excited when you asked about Tabulate. But anyhow, Tabulate is one of these drag and drop tools in JMP, and it's under the Analyze menu under Tabulate, just in case those of you that don't know. And it allows you to create these tables of rows and columns and summarize your data in a way that you can look at it, manipulate it, and such. So you wanted to look at yield, right? So you can see here as I move it around. So where would you like me to put yield, Pete?
Let's just drop it in the middle there, see what that does.
Ooh, okay. You're being brave. All right. So as a default, when you have continuous data in JMP, you get a sum. But, I don't want sum. What do you want? I think
can we do mean and standard deviation?
Oh, yeah.
Is it possible? Yeah, let's do both those.
Going for a twofer.
Yeah,
so you can see here, Pete, if I bring it up over sum and you see that blue box, it means it's going to override it. If I wanted it in addition to sum, you see that single line to the left?
Yeah.
Or I could put it to the right and you would get both like this. But let's just take sum out, drag it away, and now we have mean and standard deviation.
Great. And can we add like a nesting variable in there to look at the mean across the categorical?
Yeah, so I'm always interested in shift, see what's happening with my shifts. And we have 4 shifts here. And then sometimes, with where we get our materials from, we might want to look at that and compare shift and material. What do you think?
Yeah, can we do that?
Sure. So you can see here, once again, the line to the right, that would be, query within shift, and that would be post appending, and pre-appending would be, shift within query, depending on your question. It doesn't change the information of what you're displaying, it just the way it just reorders the numbers. So let's put it out here. Wow. So we can see here, so now we have a table with query, shift, and we have that nested, and we're looking at the overall yield and standard deviation.
So there's a lot of numbers there past that decimal place. Could we change that so it's not quite so overwhelming?
Oh yeah, yeah. So if you look down the bottom here, we have some options, and one of them is change format. And then I like to usually make it set the format for all to be the same. And let's do a fixed decimal, and I usually think 2's enough.
Yeah.
And we'll set that format, say okay, voila, look at that. So we can easily change the decimals.
One other thing, could I add the aggregate statistics to show me the overall yield average? Is there an easy way to do that in here?
Oh, yes.
Good.
So if we look here, we have the ability to add some aggregate statistics. So let's check the box. So if you look down at the bottom, here's all. And here's all for each one of the groupings as well.
Oh,
and then the total.
That's hint. One other thing, I have a fair amount of missing data. Is there a way I can include the statistics for the yield on the where I don't have data?
Sure, you have this option for include missing, and you can see here we have the mean and standard deviation for missing. I don't know if it really makes sense in this type of grouping, but you do have the ability to show that. But one of the things I do like is order by count. Do you know that one, Pete?
No, what's that all about?
Here you go. So what it does is it reorders things by the highest value.
Okay, that's great, Mary. Now, my last question, can I make this into a data table
Yes.
and how do I do that?
So once again, under the red triangle, you have the option of making into a data table. And now we can take that and potentially use Graph Builder or other graphing tools or analysis platforms we want with this summarized data table that we created.
Perfect. Well, thank you, Mary. That helps me a lot. And that was your jump tip of the day from Jump On Air.
And don't forget Tabulate.
And don't forget Tabulate. Back to you, Julian. Thank you.
Thank you, Julian. Bye.
Thank you so much, you two. And just a reminder that if you have tips or tricks that you'd like to submit in to Mary and Pete, you're able to do that actually on the community page as well. I'll just mention too that there was one question that came in over the Q&A, where to find the Tabulate. Somebody was looking under the tables menu, and I'll just remind everyone it's actually under the Analyze menu. And so that's where you'll actually find it. So thank you again, Mary and Pete, and we'll see you again next time for another tip of the day. All right, so that brings us to the end of the show, and we're really happy again that you chose to spend some of your Monday with us. Just a reminder that after the show, community.jump.com is where you'll be redirected to, specifically to the Jump On Air section. You can also get to that section just by going to community.jump.com, clicking on the community dropdown, and selecting Jump On Air. That'll get you to all of the episodes from today, the on-demand video from Friday as well as today, and all the materials that any of our speakers has pointed out. So we definitely want you to continue your learning, and there's lots of places for you to go to do that. Follow us on all of our social media. We tweet out lots of interesting things and post lots of interesting things, so certainly find us on all your favorite social media channels. Make sure to check out the program guide that you got over the weekend to see what's upcoming this week. We have lots of other great programs coming up, and we really hope you'll join us. And finally, share it with a colleague. You can share it directly from Facebook or from any of our posts on Twitter or wherever else, or just call up your colleagues and tell them to go to jump.com/JOA. And they can sign up to be a subscriber as well, and so they'll never miss any of our Jump content either. We hope you'll join us Wednesday at 11 a.m. Eastern Time. But until then, we hope you stay safe. We hope you stay healthy. We hope you're staying close, even if you're keeping your distance. Take care, everyone.